Moonshot, it's without being afraid of failure, tackling on the challenges of R&D to solve global issues through ideas of unprecedented boldness. Cool Earth aims to solve global warming caused by greenhouse gases, such as CO2. Clean Earth aims to solve environmental pollution, for example, caused by marine plastics. Planetary boundary issues caused by nitrogen compounds exceeding Earth threshold level must also be solved. There are the aims of Moonshot Goal4 to recover the global environment. President of the RITE Research Institute of Innovative Technology for the Earth, Dr. Kenji Yamaji, is the program director responsible for overseeing the various R&D projects and the overall supervision of Moonshot Goal4. With the support of NEDO, the New Energy and Industrial Technology Development Organization.
Moonshot Goal4 aims to realize the sustainable circulation of resources to recover the global environment by 2050.
Goal4 covered 3 areas. Project managers are responsible for spearheading each project.
We have yet to reach a stage where we can be optimistic about it, but the seeds for a variety of new technologies have sprouted, and we're starting to see hope.
One of the 3 areas is the development of technologies to recover greenhouse gases, detoxify and convert them into valuable materials. The effects of rising levels of CO2 and other anthropogenic greenhouse gases have become apparent everywhere, including rises in average temperatures as well as frequent torrential rain, floods, droughts, and other extreme weather. There is a demand to realize a cool Earth.
This is R&D in capturing CO2 emitted into the atmosphere and utilizing it. This Moonshot program is the first serious research carried out in Japan to find a practical application for this technology.
Direct air capture is a vital concept in this initiative. The aim is to directly capture CO2 from the atmosphere found at the concentration of only 400 ppm and concentrated. The captured CO2 is then broken down and compounded with hydrogen to turn CO2 into a resource by converting it into a fuel or chemicals. We're using a number of engineering methods for that purpose.
We will turn directly captured atmospheric CO2 into a resource using a new amine, honeycomb rotor, heat exchanger, and membrane reactor. We'll efficiently recover CO2 emitted by people in cities and use renewable energy to convert it into useful chemical feedstocks such as ethylene. That's the kind of technology we're developing to realize a cool Earth.
We'll realize energy efficiency in direct air capture through unique technology based on the utilization of unused cold heat.
We will capture CO2 and convert it into a carbon resource, realizing local production for local consumption, while also solving the issues of global warming and energy. In the world's fastest technology for absorbing low-concentration CO2 from the atmosphere through liquid-solid phase separation, liquid amines will react with CO2 to generate solid carbamic acid. We're also developing passive technology to eliminate the cost of air circulation. Concrete is indispensable to construction, and it's the second most widely used substance after water. We can use it to fix and recycle 1 billion tons of carbon dioxide per year. This is known as white carbon.
Also, we're using the power of nature to collect greenhouse gases, turn them into usable resources, and render them harmless.
By developing AERW technologies using the characteristics of Japan's rocks and application sites and using accurate carbon accounting in an agro-industrial approach, we aim for the early social implementation of negative emission technology.
I want to use the seas of Japan to cultivate macroalgae to fix CO2 and convert it into energy.
Furthermore, technology is being developed to recover nitrogen compounds to convert them into a resource and detoxify them. Nitrogen compounds are already said to have exceeded the planetary boundary or Earth's threshold level. The compounds cause environmental pollution as well as global warming and are contained in the gases emitted by industries, vehicle, and agriculture. Moonshot Goal4 aimed to realize the sustainable circulation of nitrogen by using absorbents and catalysts to convert nitrogen compounds into useful substances such as ammonia.
Prevent global warming using soil microorganisms to reduce greenhouse gas emissions. Cool Earth via microorganisms. Nitrogen compounds, such as nitrogen oxide, are pollutants found in air and water. We're developing technology to extract and convert them into useful substances. We will realize a nitrogen circulation society by the ultimate zeolite.
Marine biodegradable plastics are also being developed capable of controlling the timing and speed of biodegradation. Marine plastics are spreading throughout the environment, are difficult to recover, and accumulating in seas all over the world. Conventional bioplastics, too, barely degraded in marine environments. This is a serious clean earth issue. There has been an urgent need for the development of highly functional, innovative plastics that break down quickly in the environment.
The switch turns on, causing easy degradation the moment it's released into the environment. This is new technology that's particularly worth noting in the effort to recover the global environment.
Through collaboration between companies and research institutes, we're striving to develop a polymer that's tough during normal use but degrades quickly when a switch is activated upon being released into the ocean. We're aiming to realize a clean Earth in the future through the development of materials that biodegrade completely after turning on the switch at the right time in the ocean.
As with the other moonshot goals, these projects set targets that are difficult to attain, but have major societal impacts, and efforts are being made every day in taking on the challenges of R&D without fearing failure.
As the name Moonshot suggests, it's important to have a challenging spirit. You need to be very ambitious in taking on the challenges of cutting-edge technologies. The goals cannot be attained easily. Similar research is being carried out all over the world, so researchers will also need a competitive attitude to aim for the top. We ask project managers to have this kind of challenging spirit, and such spirit is also a target for evaluation.
NEDO's role is to promote R&D that cannot be carried out by individual organizations. In other words, we hope to promote open innovation. Through NEDO's involvement, we hope to examine areas of research where mutual rivals can cooperate.
I find out progress being made in research during on-site visit when I see what used to be a prototype turn into major equipment. I can see how the researchers have been striving over the past year or two to achieve results, and that's really fun to watch.
People are very determined to ultimately find societal implementation for the innovations we hope to achieve. When people are determined to find societal implementation, they become focused on attainable goals. But the point is to aim for goals that may be difficult to achieve. The final results are important in innovation, but it's important to take on challenges based on fundamental science. Then, finding societal implementation after that. It's a long process, but that's what we aim for in the Moonshot program.
Global warming, environmental pollution, declining birth rates, aging population, and large-scale disasters are some of the issues that are difficult to resolve. Scientific technologies are indispensable in solving these issues. This led to the establishment of the Moonshot Research and Development Program. Goals have been set with the aim of attending them between 2040 and 2050, and they will promote innovation through challenging R&D that goes beyond conventional methods and is not afraid of failure. With the aim of realizing human well-being and a brighter future, the Moonshot program has brought together the finest peak of domestic and international researchers. Steady progress is now being made to take on these challenges through the use of cutting-edge technologies from around the world, based on the idea of exciting R&D that will inspire everyone's support.
NEDO